All right. So just a very brief introduction of our background. So our company is called CSDN, Chinese Software Development Network. We are the biggest software IT professional network in China with 300,000 bloggers and then 15,000 blogs published every day and 10 million users annually, and then we have 30 million accounts. So we have a website, and then we also have our app. We also have a WeChat account. We have a video account, and then we also have our own magazine. It used to be a paper magazine, very popular, and then we stopped it a couple of years ago. But right now we are resurrecting it because people still need high quality paper kind of material to read, so that they can get some important information. So we have a great platform, and then we have all these media so that we can deliver messages and then connect people. And for the 1024 event, which happens on October 24th, we want to get the industrial academia leaders together to talk about IT development, the digital transformation, and how we use the new technology to help the every part of society, including education, finance, and then production, and so on. So in today's track, we want to talk to database companies and database pioneers, database gurus, to kind of go through. Because we know that database is such an old and traditional kind of a domain, right? Everybody knows we can do the CRUD, right? Create, read, update, and delete. What's new? But there are new things happening. So we want to talk to you guys about what's new, and then why it is exciting, and especially for also later for young students or the junior professionals. What kind of career paths should they plan or should they consider when they want to do something in this field? So first of all, I want to ask a couple questions for each of you separately, so that you can get your message out for your specific company, and then we have some general topics that we can chat about. How about that?
Great.
All right.
Sounds like a plan.
Great. So Bruce, why don't I start with you? So I heard about this database, PostgreSQL, right? So you've been a member of the Postgrad community for over 20 years. So it is the kind of from my impression, the longest database community in the world. So how has that developed? For example, in the desktop era, in the internet era, and then also right now in the open source era?
Yeah, our database goes back to 1986. So in the United States at a university in California, it was originally developed as an extendable database. So while it's relational, it has capabilities to extend it for new needs, new workloads, and that design was really sort of dormant for first 20 years or so. We didn't do a whole lot with it, but it was sort of this additional capability. But what really happened in the industry, and of course Neo4j is part of that as well, is that the data needs started to change. Because in the 90s, all the data entry and all the data output mostly was dumb terminals, or a PC emulating a dumb terminal, right?
Yeah.
So exactly as you were saying, it's create, update, delete kind of thing, the CRUD standard. What's happened in the past 15 years is so much of a shift. So now instead of just having a dumb terminal, the input and output, and maybe a printer, you've got web apps that need to interact. You've got Internet of Things. You've got GIS and GPS and full text storage of data. And so there's just now, and then, sort of JSON, and not only do you have all this data ingestion where data is coming from all these different devices, is now you've got to output data warehouse from that. So analysis of that data is becoming very important. So it's kind of like we started out 35 years ago really as just a relational standard database, but what's happened is data needs have changed over the past 15 years. And fortunately, because we were designed as extendable, we've been able to add GIS and full text search and JSON and data analytics kind of capabilities to the database pretty seamlessly. So even though we're a really old database, we look new because we can do all these interesting things with the modern data requirements. So you're absolutely right. Things have changed a lot. And if we didn't have that extendability, we'd kind of be in trouble because there is just so much of a need for sophisticated data analysis. And fortunately, we've been able to kind of take on that and sort of become modern again, even though we are so old.
So like you plan a feature way ahead of its time. And then
it's like it wasn't even me. It was a professor named Michael Stonebreaker who won the Turing Award a couple of years ago for also for Postgres, and this is some of the other databases he created. And it was the first 10 years. This extendability was a real pain in the neck because everything was abstract. I'm sure normally when you look at a data type, it's an integer, right? Or it's a text string or whatever. In Postgres, when you're in the internals, it's just this abstract type. It has a length, it has a way of getting the data in, it has a way of getting it out, it has an alignment. So everything is abstracted out. And when you're writing the code, it's like a headache to have this, have this feature basically that does this. But when we fast forward now, it sounds great and everyone loves it. But at the time, it was early years. It was kind of a pain.
All right. So in the recent couple of years, or in the next couple of years, what's been changing in the PostgreSQL, and then what are the new things you're going to bring to us?
So we just put out a release yesterday.
Yesterday? Okay.
Yeah. So it was today. It was September 30th. Postgres 14. So we're putting out a major release every year, which contains about 100 or 280, 220 features. And we're kind of, I don't think there's a single, I guess because it's an extendable database, there isn't a single direction that we go in. We're an open source project, so we have people from all different regions working on Postgres and extending it in different ways. So, we have sort of high data volume changes. We have changes in partitioning. We have changes in sharding. We have changes in the core data types. And so there isn't like a direction. In fact, I've got a slide that just shows it kind of going cloud here and usability there and enterprise over here. And every year we're kind of blowing in all these different directions. Because we're basically every year sort of looking at what the needs are, and all of our communities in all of our different countries are sort of focusing on it. China, for example, has always focused on high data ingestion, very high volumes. So the sharding capability, which does have a pretty significant feature in Postgres 14, which we just released, is actually that's a big improvement in that we just put out. Security, transparent data encryption, another thing that China seems to care a lot about. And we had a meeting in Vienna 2 weeks ago, and we're trying to move that forward going. So it's a lot of looking at markets, sometimes things are important in some regions and not in others. But because we have a global team, we can kind of say, all right, that region is going to focus on that kind of need, and then Europe is going to worry about something else, and Russia's going to sort of push us in some of the more advanced data types, and the United States is going to do its thing. Latin America does something else. So it's really a very unusual project to work on.
Wow. But I guess that's a very classic software engineering challenge, right? You have a big release, and how do you prevent new features accidentally break or cause regressions? Like someone is using the old feature happily, and they say, "Hey, here's a great thing," but it doesn't work with my old way.
It's really kind of interesting because normally the standard proprietary cycle where you sort of get some input from sales, and then you work on you create a team, and they do the
close the door.
Right, close the door, and then it goes to testing, and then finally the users see it. We don't actually do it that way because we're an open source project. All of the feature choice happens in the community, and with the developers and the users kind of all talking at the same time, and then development and patch review and then testing all happens at the same time. So you don't kind of get that developers over here and users over there kind of a problem. So if something's wrong, right away, somebody's going to see it. It's actually somewhat frustrating. You come up with a great idea and somebody in Argentina, 10 minutes after you said this, you sent this email, they're like, "Oh, that's not going to work because of this other thing." They're like, "Oh, no, what am I going to do?" So you kind of like, "Oh, well, okay, I think we can do it if we do." And then somebody from China is going to say something else, and Japan, and then Russia. And by the time you're done, your head's spinning, but you got your feedback pretty quickly. And, what's nice is that people from these other countries are also going to help you not only go through the feature, make sure it works cleanly, but also while you're designing the API, while you're looking at the patch, they're going to help you sort of through this process. So one of the interesting things about database for Postgres is that the database is not this sort of monolithic thing that you have to bolt new features onto. Because it's extendable, you're kind of organically growing it. A lot of databases, when they add data warehouse or cloud or JSON or full text search or GIS, the thing kind of comes in, it kind of sticks on the side of the product. It doesn't work with everything. It's awkward, it's clunky because of the way the development happens, because you create a GIS team and they just go and do their thing, and then they come back with a product, and then once they're done, they disappear. And then they don't really, you don't reconstitute a GIS team unless you have something to do. But what happens with Postgres, because it's open source, we're doing incremental improvements to everything all the time. So even our command line tool, PSQL, probably has 6, 8, 10 changes every year that just change little bits of it to make it a little better with whatever need. So it's a much more incremental development process than you typically would have in a company, where you kind of create a team, go do it quickly, get it done, ship it, and then move on to something else. That's really not our approach, and it served us well, because if we had done that by 35 years, we would look terrible. I mean, it would look Postgres would look like a mess. Yeah.
So I guess the key secret is that you involve our customers early on, and then throughout the process. Even though it's very chaotic, but it's much better than you give them a surprise at the end.
Surprise at the end is never good. You're absolutely right, because it's not. The difference is not only is it open source, but it's open development. So everyone's involved all the time. So it's this very chaotic relative to a corporate kind of environment, but that chaos is always injecting new ideas and new perspectives and catching problems very, very early.
Now let's switch gear to some general issues. So we ask those questions for all our panelists in this database forum. Hopefully we can present them, and we can edit the video together and present them in the final version. So the first question is that so when you look back to the changes of occurred in database space in the past 2 years. Can you use a few keywords to describe or to summarize, like what are the key changes in the past 2 years?
The past 2 years, it's funny because when you're in a project that's 35 years old, you don't really think in 2-year terms. Yeah, I mean, we've kind of realized, I think, a couple things. There's some sort of fundamental missing pieces that we need to address. First, which I alluded to it earlier, is the idea of sharding, the idea of allowing Postgres to be multi-host. That's something that China has always asked for. The idea of massive scaling has always been a key thing. So that I think the missing piece there has really sort of gotten bigger for us, and I'm hoping with Postgres 14 we just put out that we'll at least start to see workloads that are using sharding. It isn't ready for read-write workloads right now. It's probably read-only, but I'm sort of excited to see kind of what's happening in that space. Another issue that has gotten a lot bigger is the need to transparently encrypt all the data that's stored in the database. The security problems have gotten bigger across the world in a way that I don't think we could have anticipated. A lot of the ransomware, a lot of the ways that companies, particularly large organizations, are really getting hammered with attacks. So we're seeing a lot more focus on additional security features, transparently encrypting all the files in the file system that store data is getting to be. So those probably massive parallel scaling and security are probably the two big ones we've seen in the past 2 years. And it's because we're such a big project, it takes a couple of years for us to we've been working on these. I've been working on these for 5 years, but we're still sort of creeping along. I just had a security meeting in Austria 2 weeks ago talking about, adding that file encryption to native Postgres because we have just so many people now that are demanding that.
All right. So basically security, and then how can you scale?
Horizontally across. Yes. We've always scaled vertically. Bigger server, we can scale up really well, but the NoSQL has always sort of specialized in that horizontal scalability. And it's always been different for relational systems to do it because Postgres was designed to be extendable. You sort of take parallelism, which we have, you take partitioning, which we have, you take foreign data wrappers, which we have, and you kind of put them together, and you sort of now have an architecture that can horizontally scale.
But as a developer, what does that mean for a cloud native developer, especially in database space? Any thoughts? It's funny. I didn't mention cloud because I guess, as Emil sort of said, relation's been around since 1970, the relational model of what we do. And kind of the bizarre part about Postgres is that new technologies come along and we don't really seem to shift very much because these new technologies arrive. So, for example, the rise of solid state drives, SSDs, probably 10 years ago. You would think that the ability to do random access, almost as quickly as sequential access would completely upend any relational system, because that's kind of what we're, there's so many algorithms, there's so much angst about, I got to do random I/O, it's slower. And databases always are typically doing random I/O in a way typically most applications don't. But when they came along, all we really needed to do for SSDs was to add the ability to specify our random page costs in a little more granular manner, and then we were done. And 10 years in, there really isn't a whole lot more for us to do. We already have the setting. We just need to say, okay, now you may have a mix of different random page costs on different devices.
different table spaces and so forth. And that was it. So with cloud coming along, it's almost a similar story. Yes, there are some cloud-specific versions of Postgres. I know Alibaba has one with the PolarDB engine. I know AWS has an Aurora version of Postgres. So you do have some sort of cloud-specific versions of Postgres out there. But kind of the interesting part for me is that we didn't change that much. Microsoft is hosting pretty much vanilla Postgres. RDS is hosting pretty much vanilla Postgres. I know Alibaba is doing the same thing. Google's doing the same thing. There are some tweaks in terms of managing that database and scaling that database and allowing it to sort of take advantage of some of the new capabilities of cloud, yes. But those are not fundamentally changing, at least from a Postgres perspective, what we're doing. We're kind of doing the same thing. People are hosting it, self-hosting it. They're using database as a service, DBaaS kind of solutions, or they're creating cloud-specific versions of Postgres. But effectively, it ends up being Postgres, and just like SSDs, there's been some tweaks, and failover's a little different, backup's a little different. You can optimize a lot of the management of it. In fact, cloud, as Emil said, it kind of makes it easier for us because now we can deploy so much easier instead of having to sort of set up a database and then set up the failover and then set up the backup and set up the monitoring. Now we can use containers and some of the cloud infrastructure to do that for us. So now pulling up a database, instead of being this, buy the hardware and set it up and rack it and then start to install and then set up the backup and the failover and then you got to test it. A lot of that legwork is being smoothed out. So for us, cloud hasn't changed the software. It's really just it's simplified the deployment for us. And not just cloud, but containers as well. So we see cloud and containers as kind of the same, they're very similar in terms of making a relational database that has to have all this tooling around it to really be effective in the enterprise and sort of smoothing over a lot of the rough edges of deployment to allow you to automate that and deploy it in terms of at scale, in terms of tens or hundreds of thousands of servers. Cloud makes that much, much easier, and you're going to, I guess, see a lot more use of it. In fact, Postgres, in a weird way, because of the way we've designed it, worked very natively in the cloud. We're a very small footprint. It's a very compact piece of software. It relies heavily on the operating system. It doesn't try and do a lot of fancy tricks that would normally require special hardware. So when the cloud came along, we just kind of moved to it, and people deployed it in a very similar manner, in a very simple manner.
Yeah, actually, Bruce mentioned the SSD and then also some of the infrastructure. In database applications and database system, people care about how data is stored and then how can we quickly retrieve those data. So how can we integrate the cloud infrastructure and database? For example, I know that my data is stored in a container, but beyond that point, I do not know whether or not it's stored in the SSD or underneath what version of Linux is used or what kind of hard drive they use. Would that decrease the flexibility or decrease the effectiveness of database? Like, in order to optimize for database, do you have to know from the top all the way kind of to the bare metal? Or do you say, okay, I trust that container will take care of things for me?
Yeah. So as a relational database, people are always, the traditional way you do it, is you go out and you spec out the hardware and you figure out how many DIMMs you're going to put in the slots and what type of channel you have your I/O and how that channel is mirrored. And, there's people, I don't know, database people just love that stuff. There's this sort of nirvana of sort of getting all those details and making it go as fast as possible. And I have to admit, Postgres never really went down that road. I know people who use Oracle and DB2 and Microsoft, and they're just like, they fanatics about knowing every little detail about what's going on and how things are stored in all the devices and IO channels and fiber channel and all that other stuff. Postgres has always been sort of written as a generic database on top of generic hardware. So there is never been a huge focus on trying to get that last 1%. I don't know if Emil has his case, but what we found is that you can provide a tuning set for your application and for your developers that covers like 95% of pretty much whatever one wants. So that's probably 100 settings or something like that. But if you want to handle that last 5% of workloads, that number of config parameters goes to 1,000. And I even have a blog entry on a website where it sort of says, what are the ideal number of config parameters? Because Oracle's way on one end, where if any customer would, if adding a parameter would cause a customer to buy, they added the parameter, right? Okay. And when you do that for enough years, you start to look at the product, and it is a mess. There's these undocumented parameters. I was in Europe, and there was some people there who spend their whole time trying to figure out how Oracle does some special thing, and there's this parameter that, we've always sort of stayed away from that because we're a generic.
Well, that's why we need consultants.
Right. Yeah. Well, exactly. It sort of is this self-propelling thing, but we've always been a generic database for generic workloads, and we've always abstracted out that lower level. And if you needed something really special, you could use another database and integrate that with Postgres or whatever. So that was, people used to complain, we don't have optimizer hands. We don't have some of the very fancy tuning things that you might need for special hardware. But because we never went down that road, you can't tune Postgres to get that last couple percent of performance out of it. We just don't have the settings. We don't want to give you the settings because the product becomes so complicated at that point. Certain settings interact with other settings in ways people don't predict, and they get into much worse problems than they're trying to solve. And we basically kind of shut off the knob and said, you're just not going to be playing over there. So fortunately, when cloud came along, it was like, all right, well, it's generic. It's a generic file system. We never did anything fancy with the file system. We don't have raw devices. We don't have special kernel calls to do fancy I/O tricks. So effectively, new file system. All right, fine. It's a file system. It handles the standard POSIX requirements. We're good. And I think one thing we've seen in the cloud is a move, is sort of an increasing validation of that. That people are like, if it's too slow, there's a couple parameters we're going to change. But if it's too slow, we'll just configure a larger server in the cloud, right? We're not going to sort of, spend a week trying to play with one parameter that's somehow going to get us another 5% of performance. We're just going to we'll just get a bigger server, And I think that sort of tuning it for your special server that sits in a corner somewhere in organization, hopefully that period's over, and people see data as a much more fluid thing that they just deploy. Yes, they should know where the data is. Yes, they should understand what the major parameters are, but also, and we have a lot of very sophisticated indexing methods which allow you to work with some of this newer type of data. You should know those things, but effectively the cloud is an abstraction that has been moving forward, pretty much on the abstracting of data has been happening for 20 years or so.
Yes.
And that's just continuing in the cloud. And fortunately, we haven't had to change a lot. It's kind of the same thing for us. But there are a lot of people who are saying, okay, we need more horsepower. Okay, we'll just configure, more cores, more memory. better I/O channel for our database, and then the problem solved, and we'll move on to other problems. So I think that's probably a healthy thing.
All right. In the interest of time, we want to move to the last two questions. As mentioned, many of our audience are college students. I think about 30 to 40% of our website audience are college students. And then for some reason, they still learning database as the traditional relational database, like a CRUD thing. And now, of course, you probably can get an entry-level job, but as Emil mentioned that we are moving towards different directions. So people might get confused or anxious, like, what should I do, right? Should I learn cloud? Should I do AI? Should I learn Python and statistics? So if I really want to handle data, and then in the cloud-driven era, what is my growth path? Any suggestions from both of you?
Yeah, I was in academia for 5 years, and I've worked with a lot of universities over the past 20. In China, even I know I spent at Renmin University in Beijing.
Yeah, that school is famous for its database technology.
Yeah, so I've been there, and I'm not going to talk about them specifically, but what we've seen in the United States and Europe primarily is that a lot of the instruction is often focused on yesterday's technology.
Yes. Very stable,
very stable, right? And I'm kind of embarrassed by that as a former academic, because we want to think that we're giving our students the best picture of the industry, so they're going to be very useful and productive going in. I worked with a university here in Philadelphia, and they were very forward thinking and got me involved, and we were doing a whole lot of very interesting things. And then some new people came in and said, oh, that doesn't fit with relational theory, and it isn't in the textbook and whatever. And I'm like, well, yeah, because anyway, that's not the industry today. So what happens, unfortunately, I think, is that the academia has a tendency to go with very old, sort of stable theory of relational and second normal form or third normal form, and you learn all that stuff, and that is super important. But practically, they're often focused on proprietary old school databases. They're focused on old workloads that exist but don't exist to the extent that they do today. So as for students, I would definitely question whether what you're learning in school is exactly matching what is happening in the industry. And if it isn't, then it's sort of a requirement to sort of say, hey, we need to. But I just find academics to be very resistant to opening up to new workloads, new technology. I mean, Postgres is open source. It's an ideal start in the academia. It not only allows people to use the database, but to look inside the database to see how the optimizer works and how the storage system works and how the indexing works. And so they can see it at multiple levels and understand it at a level that you can't with proprietary databases. Yet if I walk into a typical university in the United States and Europe, they're typically still using the standard proprietary relational databases because the professors don't want to learn something new. They aren't thinking forward. We have had some universities, for example, in Russia, I have a team who's been sort of championing Postgres across universities and sort of showing the value of that. And I've seen it in other countries as well. So in China, I would love to have some kind of advocate that really pushes current database needs into universities.
Yes.
Because when we did this in Russia, it kind of swept across the entire landscape of what they're doing, and it greatly increased the number of people who knew about our database, who could work in our database and also could improve our database as internals developers. So in Russia right now, the jobs, for example, for somebody who can internally improve Postgres are tremendous because there's just so much, it's like a completely different thing that didn't exist in these other proprietary worlds. So, and again, as we've said before, and Emil kind of made a good point, there's so much more data ingestion now from mobile, from Internet of Things, from just all over the place, browser and GIS, that modern developers have got to understand those things, and they've got to understand data that doesn't fit in that relational model anymore. Right? I mean, as a relational system, we ran the first 10 years just focusing on relational. And it was really the people in Russia who started to say, you need to get full text search into the database. You need to get JSON in the database. And we kind of looked at it. We're like, oh, okay. If you think that's important, we can do it. We're extendable. We can handle that. And we found out that the Russians were way ahead of us in terms of seeing where the data needs were going, and having a system that can do relational and non-relational together is now a foundation of who we are. But it's only because we listened. And I think a lot of these universities have to do a little better job of listening to where the market is, and do a better job of presenting the kind of, because you're going to need to make decisions as an application developer, where to go and what to do. And I often think that people are just stuck in relational only, which is unfortunately the way that a lot of the universities teach, are not being served well, because the market does require that much more flexible requirement. And universities that are doing that, I think, are doing their students a great service.
So maybe one suggestion is that start to use open source, start to join communities. Start to play with some products.
That is a completely different game changer that didn't exist, and most of the professors, I don't think, understand the value of being able to drill down into a relational system. How does the parser work? How does the optimizer work? How does the executor actually do what it does? That's why I got involved with Postgres, 25 years ago, was that curiosity. And I think it gives a much richer, not only does it match where the market's going, it gives a much richer educational experience for the students. And I'm hoping that would, we've seen some successes in some countries, but I feel like we're still way, way behind. And we need almost advocates in every country to sort of work through the academic channels to kind of get these newer technologies into universities.
So one last question. So I mean, we are a conference. We are holding a conference in China, and then most of our audience are in China. As I mentioned, 30% students, probably 30% IT professionals, and then some the CIO, CTO level influencers, and the academia. So when you work with Chinese developers or Chinese communities, any advice to them? Because we are building, for example, for the Neo4j, Mr. Zhu in the audience also in our call also work with us to build an online community of Neo4j, try to recruit some students, which is great. And then we also already have a network and user base of Postgres. But besides that, I mean, those are kind of let's go do a forum, right? Let's do a social network. Besides that, any new things that you can propose that we can kind of help the engagement between the company and the developer and in China?
Yeah, I have to admit that China was sort of a slow adopter of Postgres. I'm obviously I travel a lot before COVID. It's typically 90 days a year I'm out somewhere, and usually in another country, not as much in the U.S. And, we've always seen very weird adoption trends. Like, for example, Japan was probably the biggest adopter of Postgres in my early years. They were doing stuff with Postgres that I couldn't even fathom some of the things they were doing. and then it kind of swept into Europe. Europe was leading, was far greater in adoption than the United States for many years, and then it kind of swept in the United States and Latin America. So those are kind of the axes that I think of. But probably the big change for me in the past 2 years in terms of development, and maybe 4 years, is China. It really started with Hygo, sort of taking Postgres and developing a custom version of it. Then Alibaba went really big into their adoption of Postgres. I've been to their conferences in Guangzhou a couple times. Huge,
yes.
And a huge company really pushing Postgres in China. And the big switch there was all of a sudden now Postgres was sort of invisible for decades, and now all of a sudden it became huge. And then Hygo is another company that's kind of been pushing it. So we have a lot of people in China now working in the Postgres community and the developer community, helping to improve Postgres. And that was definitely not true 4 years ago. So I think what happened in China is that it kind of like, it isn't a country that does things incrementally. It kind of doesn't do anything, and then all of a sudden a big company kind of puts the stake in the ground, and then boom, oh yeah, now we're Postgres, right? And I've done, I think, 2 or 3 China events already this year. Unfortunately, all virtual. But that didn't happen. That didn't happen in any other year before me. So the good news is that we see a lot of activity. There's a lot of user group things that are going on. We have a lot of conferences going on. And again, because Postgres is this global, amorphous, open thing, people, wherever they are in China, can be fully engaged. You don't have to be in Silicon Valley. You don't have to be in Berlin. You don't have to be in even Shanghai or Beijing to be fully involved in what we're doing. So unlike typical groups that are like headquartered in large cities, we're all over the place. So I would basically say that China in the past 4 years has greatly adopted Postgres in a way they hadn't ever before. But also now there is so much more opportunity to be involved in that global process, and also to become globally known. We've got a bunch of people now that I look at Chinese names, I'm like, that's the guy who does X for us, or Y, right? So I think there's an empowering process here, whereas before you had to I got to join X company, right? And that's how I'm going to make my mark. Now it's much more freeform, right? And the idea of somebody becoming an expert in whatever city they're in, wherever they are, is now a great possibility. And then we're going to invite them to speak at conferences, and then they're going to be hired by these big companies because that talent is so hard to find that people will find you if you're good. And I think that's a great leveler of opportunity, because typically, the opportunities were in the big countries and the big cities. And if you weren't in one of those regions, you kind of were second class. And that's not true anymore. There's just so many ways. And I think the internet's really done that to kind of open up that communication where you're still going to get together for events and conferences, and that's important. But the day-to-day work now, even pre-COVID, and I've worked from home for decades, is now virtual. And people really need to take ownership of continuous learning. I would say the idea that you're going to go to university and then just take that and use that same information for decades is not going to happen anymore. The people who can learn on their own and really embrace and find the information that they need, those are the people who are going to really succeed.
Okay. Great. Thank you. Thank you very much.